Welcome students to another video lecture with Mr. Connect. So this lesson we're learning today is from chapter 5, section 5 in our textbook, and we're focusing on proportional and non-proportional relationships. And when you copy down both these slides in just a moment here, please make sure to do it really neat, because we're going to reference this proportional column on the left and this non-proportional column on the right quite often as we go forward. So go ahead and pause here and copy down what you see. Okay, welcome back, students. So our essential question in this lesson is how do we determine if something is proportional or non-proportional? And then, if we figure out it's proportional, how do we write an equation for the proportional relationship? So it's actually quite simple to determine if something is proportional versus non-proportional. We're going to be recycling the skill of creating unit rates. And we're going to learn that this unit rate is something in our future called our constant of proportionality. And also that if they have the same unit rates, that is actually going to jump into something we'll call slope not far in our future. So on this lesson here, we're going to focus on if something is proportional and if something is non-proportional. So let's talk about proportional first. If something is proportional, it's going to have a constant ratio. And what that actually means is the same unit rates. So we can reference our steps on how to create unit rates if we're confused at all. And we're going to give this a special name in this lesson. When we do find out something is proportional, meaning they have the same unit rates, they're constant ratios, we have to call that thing the constant of proportionality. A really complex word. I'll explain it a little more in class, and we're actually going to learn in our future that this thing is just called the slope of a line. For something to be proportional, it has to have the same unit rates, constant ratio, or constant of proportionality. It also must go through the origin when we graph it. And lastly, if it is these two things, one, same ratio, and two, goes through the origin, turns out that we can write an equation for it, y equals kx. If something is non-proportional, that means the unit rates were not the same, or they did not have the same constant ratios. And also, it could have the same constant ratios, but if it does not go through the origin, we can't call it proportional either. So we have these two categories. Does it have the same unit rate, and does it go through the origin to call it proportional? If it is proportional, one more time there, I'm going to scroll down a little bit. This k inside of our equation here is the constant of proportionality. Or it's that unit rate that you have found that is consistent with all the ordered pairs in the problem. Okay, so we're going to jump ahead and we're going to have two examples of this in this lesson today. So if you don't mind, copy down what you see, pause right here, and we're going to do some math. Okay, welcome back, students. Okay, so first off, how do we determine something has proportionality or is proportional? Step one is going to be finding the unit rate for each set of data. And when I mean set of data, I mean the ordered pairs, those numbers that go together. For example, when you bought 1 pound of coffee, it will cost you $3. Those two are the sets of data that we're going to create the unit rate from. If all the unit rates are the same, it is proportional as long as it goes through the origin. If all the unit rates are not the same, it is not proportional. And I'm going to need a little room to do this problem. And we're going to be recycling words we've started to hear, and we're going to start using that vocabulary a little more. So in this problem, we're determining whether the cost of coffee is proportional to the number of pounds. So which one of these is independent and which one of these is dependent upon the other? So we've already started talking about independent and dependent, but we're now going to start to be asked to master this. And I think about this when I go to the store. So what determines how much you're going to cost at the store? It kind of matters about how much coffee you will buy. So in this problem, the amount of coffee is the independent variable. And when we have the independent variable in math, that's usually an x value if you're thinking of your coordinate plane. And the cost is dependent. And I know that's kind of messy, so it's just independent without the in on it. And that is normally on our coordinate plane going to be called the y variable. So that vertical axis and the independent goes on the horizontal axis. But step one here is asking us to find our unit rate for each set of data. So we have 4 different sets that go together here. And we're going to do 4 different problems. And let's start with the first one. Whenever you're finding the constant of proportionality or the unit rate, you want to put the dependent on the top, and we put the independent on the bottom. Okay, so we're going to hold that pattern with each set of ordered pairs here. So let's go with the first set. We have $3 for 1 pound. If we're making a unit rate here, we have to create a denominator of 1. And what do you know? It's done. That first math problem was easy. So it turns out every $3 per 1 pound. So now we have to use the next set of data, this next ordered pair, to find out if it has the same exact unit rate. So we're going to put $6 on top and 2 pounds on the bottom. And to make a unit rate here, we have to divide the top and the bottom by the number 2. And that simplifies to $3 per 1 pound. Okay, well, so far we have the same exact unit rate. It's not enough just to check 2 ordered pairs. You need to have a pattern to show at least 3 ordered pairs. And in this problem, since it gave us 4, we're going to check all 4. So the next set of ordered pairs we're using is here. And again, we're going to put that dependent on the numerator, $9, and the independent on the denominator. And to create a unit rate here, we have to divide the top and the bottom by 3. And once again, that unit rate is $3 per 1 pound. So right now we've proven, right, there's a pattern of $3 per 1 pound. We're just going to double check that 4th ordered pair here also has the same unit rate. So it's $12 over 4 pounds. We're going to create the unit rate, divide the top and the bottom by 4. And what do you know? It's still $3 per 1 pound. So far we know that this relationship is proportional because they all have the same exact constant ratio, which is the unit rate. And we have a new name for this $3 per 1 pound. That will be called our constant of proportionality. The last thing we have to check is if this would go through the origin when we graph it. And we can actually just think about this. If you were to spend no money at all, or sorry, buy no coffee at all, how much would it cost? 0. You're right. And that's the ordered pair 0, 0. So we have just proven that this relationship is proportional. The relationship of pounds of coffee to dollars, or cost, is proportional. Not too difficult, right? Again, our math problems are going to get longer, but I don't think they're actually getting much harder. So that was a great example of proportional. Let's go to example 2 here. So copy down what you see here, and we're actually going to do this problem in class on Monday. But do go ahead and copy what you see, and you will need at least a thumbs space below this. So you students know who I'm talking about there. Leave a good amount of space to do this problem. Okay, welcome back. So now the second part of this lesson is how to create an equation from a proportional relationship. And my goal here is not to make you write constantly in this lesson here. So we're going to use example 1's information when we start solving an equation for a proportional relationship. Go ahead and pause here and copy down what you see. Okay, welcome back. Okay, so identify the constant of proportionality. Well, we learned in slide 1 that something that's proportional has a constant ratio, which means they have the same unit rates. And a new name we're going to call the same exact thing is the constant of proportionality. So we already discovered that inside of this lesson here. The constant of proportionality is $3 per 1 pound. I know I'm jumping around here, so we're going to go back to our problem here. So we actually found K. K in our first problem is equal to $3 per 1 pound. We also analyze the problem and know that the independent is the amount of coffee we buy. So I'm going to call it P for pounds of coffee. And the dependent variable is the cost of the coffee. So, well, cost seems pretty easy there. We're going to call dependent variable C for cost. Okay, and you saw in the first part of the lesson here, or on the front part of the note, that Y is the dependent and X is the independent. So since we've already figured out our constant of proportionality, we know what the independent is in this problem. We know what the dependent is. We're on step 3. All we have to do now is substitute into that equation y equals kx. So instead of a y, the dependent variable in this problem is the letter C. We write an equal sign. The K, or constant of proportionality, is $3 per pound. So we're going to substitute, instead of writing a K, we're going to write the number 3. And instead of writing an X, we're going to use the independent variable pounds we created, P. And there's our equation. And what we can do with this equation now is our table only went up to 4 pounds. We can now know how much it would cost if we chose to buy 20 pounds of coffee. All we would do is substitute a 20 in for the P. 3 times 20 is 60, so we would have to pay $60 for this amount of coffee. So what we have actually done is created an equation that gives us any amount of cost for any certain amount of pounds of coffee we buy. Well, that's today's lesson, class, and we're going to continue this lesson in class on Monday morning, and I hope all is well. Remember, if you have any questions, please write down in the question column those questions you're having, and please add anything you feel like I left out in this note. Can't wait to see you soon. Talk to you all later.